Alright, let's look at the ODE Practice Exam 4, problem number 18. Alright, so let's find the inverse Laplace transforms of the following functions. Alright, so let's look at part A. Alright, so first thing we need to do is we have to do a partial fraction decomposition. And this one, you can actually decompose it into 1 over I'm going to write it as s squared plus 1, right, minus 1 over s squared plus 9. I'm going to write 9 as 3 squared, and I'm going to write 1 as 1 squared. Right? Then you can see that this fits the form of sine of kt. So here, this is the formula there. So sine of kt. Actually, both of them. And we just need to tweak a little bit, right? So first one looks like it fits exactly. K is 1 in this case over s squared plus k squared. So we got that. Here, k seems to be 3, so we would like to have a k on top. Then one thing we just need to do is just I'm going to multiply top by 3. Oops. Right. So what I'm going to do is I'm going to multiply by 3. Right. So then divide by 3. So I'm going to just do that. Right. That way it fits exactly the form k over s squared plus k squared. Right. Then if you want to find the, so you take the inverse Laplace transform, you get f of t, which is equal to, right? So this one with the sign with k equals 1, so this is just going to be sine of t. Right, here's minus 1/3, so that's just a constant. This is again a sine. And k is 3, so sine of 3t. Alright, so that's what the inverse Laplace transform of part A. Alright, then let's move on to part B. So part B actually fits exactly in the form of, let's see, this one. Alright. So k being 1, so you can actually put the square there. Oh, actually, right. So I have to do put the square there. Right. So k is 1, and a is 3. So this is our a. Right. So it fits exactly. So we can just take the inverse Laplace transform directly from there. Then you would get f of t is equal to, so a is 3 in this case, so it's going to be e to the 3t, and k is 1, and so sine of k is 1t, so sine of t. Alright, so we have inverse Laplace transform for part B. Alright, part C, we need to do, we need to complete the square here. So denominator, we're gonna complete the square. Right? So you have we have s squared minus 6s. Right? Then we would like to have, let's see, to complete the square, we would like to have 36 there. Right? But we have 34, so you just have to subtract 2. Right? On top, I'm gonna just pull out the negative 7. Then you would have s minus 3, right? Alright, let's complete the square on the bottom. So you're going to get this. Alright, so I might put the negative 7 right in front. Then you have s minus 3. Then here, if you complete the square using those 3 terms, then you will see that you're going to get s minus 3 quantity squared. All right, minus, I'm going to write 2 as square root of 2 squared. All right, so this fits exactly the form of this guy right here. All right, so in this case, A is 3, all right, again, so this is A. Oops, that's not what I wanted to do. So here, this is A value. All right, so here, this is the K value. All right, so if you take the inverse Laplace transform, you will end up getting f of t is equal to, right, -7 is just a constant, so put it there. Right, then you have a e to the a is 3, so 3t, and then you have a cosine, so cosine of, right, k is square root of 2, so it's a square root of 2t, right? Maybe I'll do that. All right, so that's the inverse Laplace transform of part C. All right, that's it. I hope that this was clear.